All right, ready to go depth. Today, it's all about the respiratory system.
Deep dive time.
We've got lecture notes, diagrams, even someone's really detailed
Oh,
annotations.
yeah, someone's paying attention.
I know, right? Clearly a fan. But for everyone listening, think about it. When you take a breath, what happens to that oxygen? How does it get to your cells?
Yeah, it's a pretty wild ride when you think about it, and it's happening all the time,
Yeah,
automatically.
totally. So our notes start with the basics, like what even IS breathing.
Okay, so breathing, or technically respiration, is like the mechanical process of air going between your lungs and, well, the outside world.
So it's not just about taking in oxygen.
Right. It's a two-way street. We take in that oxygen our cells need, but we also got to get rid of carbon dioxide. That's the waste product.
Like a trade. Oxygen in, CO2
A
out.
perfect analogy.
Mhm.
And get this exchange, it's not just happening in one spot. We've got two types of respiration, external and internal.
Two types. Okay, now I'm curious. What's the difference?
So think of external respiration as the gas exchange that's happening right there in your lungs. Oxygen from the air goes into these teeny blood vessels called capillaries
And the carbon dioxide goes.
in the other way. From the blood into the lungs, then whoosh, out you breathe it.
Okay, so that's how oxygen gets into the blood. What about internal respiration then?
That's happening at the same time, but it's deeper, literally.
Oh.
This is where that oxygen-rich blood from the lungs actually delivers the oxygen to all your body's cells and picks up their CO2 waste.
So external respiration is like the loading dock at the lungs, and internal is the delivery route to each cell.
You got it. It's a beautifully coordinated system, really.
Well, speaking of systems, our notes get into the anatomy of breathing, and this is where things get a little more complicated looking.
Yeah, the respiratory system is this whole network of airways, but it's amazingly efficient when you break it down. It all starts with your nose, the VIP entrance for oxygen.
Right, and the nose does more than just let air in, doesn't it? It's got those little hairs.
Oh yeah, the cilia. It's not just an open door. The nasal cavity filters out dust and stuff, warms the air up, even moistens it.
Prepping it perfectly for the lungs.
Exactly. From there, the air goes down the trachea, or windpipe. Still lined with those cilia, working hard. They're constantly sweeping stuff upward to keep things clear.
Like tiny little brooms, keeping the airways spotless.
Yeah.
So what happens after the trachea?
So then, the trachea branches off into two bronchs, one for each lung,
Okay.
and each bronchus keeps branching. Think of it like the roots of a tree, but upside down.
Getting smaller and smaller.
Yeah, they become these smaller tubes called bronchioles
And it all ends.
at the alveoli.
Yeah.
Millions of tiny air sacs, bunched up like grapes almost.
The alveoli, those are key for the gas exchange, right?
You know it. They're the stars of the show.
Mm-hmm.
Each one is covered in a web of capillaries, those tiny blood vessels we were talking about.
Right. Right. So that's where external respiration happens. But how does the oxygen actually get from the alveoli into the blood?
Yeah.
And CO2 the other way? They don't have like tiny little doors, do they?
It's all about diffusion. Imagine two rooms, right? Separated by a thin wall. One room's packed with people, the other's almost empty.
Okay, I'm picturing it.
What happens?
People would move from the crowded room to the less crowded one until it evens out.
Exactly. That's diffusion. High concentration to low concentration.
Wow.
The oxygen in the alveoli is crowded compared to the blood in the capillaries.
Ah, I see.
So it naturally flows across that thin wall into the bloodstream.
And the carbon dioxide.
Same idea, just the opposite direction.
Yeah.
It's more concentrated in the blood, so it moves into the alveoli to be exhaled.
No tiny doors needed, just molecules doing their thing.
Right. And here's another cool thing. These alveoli, even though they're super thin, they don't just collapse after each breath.
What keeps them open?
They're coated with something called surfactant.
Surfactant.
It's like an anti-stick agent. Reduces surface tension so the alveoli stay open and ready for the next breath.
Wow, so we've got these tiny little non-stick air sacs. That's amazing. But we don't have to think about each breath, so what's controlling that rhythm?
Good question. Deep in your brainstem, there's a part called the medulla oblongata, and it works with pons. They're like the control center for your breathing.
Ah, so they're calling the shots.
They are. And they get constant feedback from these sensors called chemoreceptors. They're in key blood vessels.
What are those sensing?
They're monitoring oxygen and CO2 levels in your blood. Like, let's say you start exercising.
Yeah,
Your muscles use more oxygen, produce more CO2.
makes sense.
The chemoreceptors pick up on that change and send a signal up to the medulla and pons.
Like, hey, we need more oxygen down here.
Exactly. More oxygen, less CO2, please. And the medulla and pons, they adjust your breathing rate and depth.
It's like a constant feedback loop, keeping everything balanced.
It is. It's happening all the time, whether you're aware of it or not.
Amazing, right? This is blowing my mind. It makes you realize how much is going on without us even thinking about it.
Yeah, breathing is definitely more than just, breathing.
This is incredible. Makes you appreciate what your body's doing every second.
Totally. It's a whole world happening inside us.
Well, we're just getting started. There's a lot more to uncover in this deep dive, so stick around.
Yeah, we're just getting warmed up.
We'll be back with more fascinating respiratory insights in part 2.
Can't wait. Welcome back. We're diving deeper into the respiratory system.
Ready for round 2.
All right, so our notes here, they get into some really interesting anatomy stuff.
Oh, good. Lay it on me.
Let's talk larynx. You probably know it as the voice box.
Ah, yes. The voice box.
Less than only. It's that structure in your throat that lets you, make all those lovely sounds.
Responsible for all the podcasts in the world. But it does more than just talking, right? I vaguely remember learning about that.
You're right. The larynx is a multitasker.
Big time.
It's also super important for protecting your airway.
Protecting the airway.
Like, think about when you swallow
Right.
food, drinks. They got to go down the esophagus to your stomach,
Yeah.
not down the trachea into the lungs.
That would be bad.
Very bad. So the larynx, it's got this little flap of cartilage called the epiglottis.
The epiglottis.
When you swallow, that little flap flits down, covers the trachea.
So nothing goes down the wrong pipe.
Exactly, like a trapdoor or a gatekeeper, making sure everything goes where it's supposed to.
Ooh, that's a relief. Glad we have that system in place.
Yeah.
So all this is happening up top, but what about the lungs themselves?
Ah, yes, the lungs. The stars of the show, really. And their structure is pretty amazing.
Yeah.
They're divided into lobes. The right lung's got 3, the left has 2.
Why the difference? Is one lung slacking off or something?
Haha, no. The left one's a bit smaller to make room for your heart. It's over there on the left side of your chest.
Ah, so it's all about maximizing space. Efficient.
Absolutely. And inside each lobe, there's even more division, smaller segments, each with its own blood supply, air supply.
Wow, organized chaos.
In a way. Now, remember those alveoli? The tiny air sacs we were talking about?
Oh yeah, the gas exchange happens there.
Well, picture this. Each alveolus is just surrounded by a ton of capillaries. Those tiny blood vessels.
Like they're all packed in there together.
Yep. And that's important because the closer they are, the faster that diffusion can happen.
Makes sense. Shorter distance, faster exchange.
Exactly. It's all about efficiency. Now, there's also this thing called the pleural cavity.
The plural what now?
The pleural cavity. So each lung, it's got this double-layered membrane around it called the pleura.
All right.
And the space between those layers, that's the pleural cavity. And it's filled with a thin layer of fluid.
Fluid, what's that for?
Well, it's super important for smooth breathing. It lets the lungs glide against the chest wall as they expand and contract.
Like a lubricant.
Exactly. Keeps things moving smoothly. Plus, it helps create a slight vacuum so the lungs stay inflated.
Wow, so it's lubrication India suction system. That's pretty neat.
Right. The body's pretty amazing when you think about it.
So we've been talking about how amazingly this all works, but what happens when things go wrong? Our notes do mention a few respiratory conditions.
Yeah, there are a number of things that can affect the respiratory system. It's good to be aware of them.
For sure. We talked about pneumonia, the lung infection. What are some other common ones?
Well, there's COPD, chronic obstructive pulmonary disease.
COPD, okay.
It's actually a group of conditions like emphysema and chronic bronchitis. Basically, they make it harder to breathe because airflow is blocked.
So it's like a long-term lung problem.
Right. Smoking is a big risk factor for COPD,
Ah, yeah.
but it can also be caused by air pollution or other stuff you breathe in.
Another reason to avoid those smoky karaoke bars.
Definitely. And then there's asthma. That's chronic inflammation in the airways, so they narrow and produce a lot of mucus.
Right, and that can cause that wheezing sound, like you were saying before.
Exactly. It's like the airways are whistling because they're so constricted.
This is all fascinating stuff. It's amazing how much we can learn about the lungs just from listening to them.
It is. And it shows how important it is to, pay attention to your breathing.
For sure. Well, we've covered a ton of ground in this part of our deep dive.
We have. We've talked larynx, lung structure, even some conditions that can affect this whole system.
It's incredible how intricate it all is and how much we rely on it every second of every day.
Absolutely.
But wait, there's more. Stay tuned for the final part of our deep dive where we'll wrap up this respiratory adventure.
See you there?
Welcome back for the final part of our respiratory system deep dive.
We're in the home stretch.
I feel like we've already uncovered so much.
We have, from the nose to the alveoli, the whole 9 yards.
But the notes keep going. This section is all about how healthcare pros actually check out the respiratory system.
Oh, yes, the exam room. It's not just listening,
Right, there's more to it.
They use palpation, too.
Palpation.
Yeah, it's basically using their hands to examine the chest.
So they're like feeling around.
Exactly. Checking chest expansion, making sure things are symmetrical, feeling for any tender spots.
Interesting. So they're looking for anything that feels, well, off.
Yeah, like if one side of the chest isn't expanding as much as the other, that could be a sign of a collapsed lung or fluid buildup.
Wow, that's pretty incredible. They can tell all that just from touch.
Pretty much. It's a lot about experience knowing what to feel for.
It's like a whole other level of detective work.
It is. And then there's percussion.
Percussion? Like drums.
Uh-huh. Not quite. It's tapping on the chest with their fingers and listening to the sounds.
I'm picturing a doctor with tiny drumsticks now.
Okay, maybe not drumsticks, but the sounds they hear tell them something. A normal, air-filled lung will have this resonant sound.
Resonant, okay.
But if it sounds dull, that could mean there's fluid in the lungs, or even a solid mass.
So they're basically mapping out the chest from the outside in.
You got it. And then, of course, there's auscultation, using the stethoscope to listen to the lungs.
Ah, yes. The trusty stethoscope. Crackles, wheezes, raunchy, all those fun sounds.
Exactly. Each one tells a story, helps them figure out what's going on.
It's amazing how much info they can get just by listening and feeling.
It is. It's like piecing together a puzzle.
So we've talked about the system when it's working well, but our notes also mention how things change as we age.
Ah, yes. Time marches on. For the respiratory system, too.
So what happens as we get older? Do our lungs get, like, winkly?
Not quite wrinkly, but definitely less youthful. The muscles we use for breathing, they weaken a bit.
Makes sense.
The chest wall gets stiffer, too.
So it's harder to take those big, deep breaths.
Yeah, and the alveoli, they might not be as good at exchanging gases anymore.
So it's just like a general slowing down of the system.
In a way, yeah. That's why older adults are often more prone to respiratory infections and might get winded more easily.
Makes sense. It's definitely a reminder to appreciate those healthy breaths while we have them.
Absolutely. Take care of your lungs. They work hard for you.
So after this deep dive, I feel like I have a whole new respect for this system.
Me too. It's pretty incredible when you think about it.
From that first inhale to the oxygen reaching every single cell.
It's nonstop, behind the scenes, keeping us going.
It makes you realize that breathing isn't just automatic, it's this amazing feat of coordination.
Right. So many parts working together perfectly.
Well, on that note, I think we've reached the end of our respiratory journey.
We've explored a lot today.
We have. It's been fascinating. And hopefully everyone listening has learned something new about this incredible system.
And maybe gained a little more appreciation for each breath we take.
Absolutely. Thanks for joining us on this deep dive into the respiratory system. We'll see you next time for a whole new adventure.
Until then, breathe easy.